Section 8 is about graphing linear inequalities. Let's go through an example and see how we go about graphing the inequality 2y minus 5x is less than or equal to 8. So the first thing we do is decide that we are going to graph 2y minus 5x equals 8, which we know is a linear equation, which will give us the graph of a line. We will do that by plotting our y-intercept and our x-intercept and using those 2 points to form our line. In order to find our y-intercept, we know that is when our x equals 0. So if we plug 0 in for x, we get 2y equals 8 and our y equals 4. That gives us our point 0, 4. That point is shown in green. For our second point, we are going to determine our x-intercept, and that is when our y equals 0. So if we plug 0 in for y, we get our x to equal negative 8 over 5. That means our second point to plot is negative 8 over 5, 0. This is also shown in green. The next thing we need to do is connect the 2 points. Since we are graphing an inequality and not a normal linear equation, we will either choose to draw a solid line or a dotted line. For this example, we are going to use a solid line because our inequality is less than or equal to. So we're including those points because it is equal. Just like in a normal inequality on a number line, we would put an open circle when the number is not included and a closed circle when the number is included. So we use a solid line when there's an equal to sign, and if there was just an inequality that is not equal, so if it was just a greater than sign, we would draw a dotted line. The line I just drew is actually the boundary for our inequality. So now, in order to complete the graph for our inequality, I need to shade everything to the right to represent the solution set of our inequality, or everything that's less than or equal to 8. The last thing we want to do is test or check that the graph I drew is correct. So I am going to pick a point in this shaded region and test to make sure the inequality still holds true. So I'm going to pick the point 0, 0, which is our origin, because that point lies in our shaded region. So when I plug in the point 0, 0 for x and y into our inequality, I determine that 0 is less than or equal to 8. And is this true? Yes, that is true. So our solution checks and we know that the graph we drew is correct. For our next example, we are going to graph the inequality y equals the absolute value of x minus 1. This absolute value has 2 conditions to consider. We need to consider when x is less than 0 or negative numbers, and when x is greater than or equal to 0 or positive numbers, including 0. We can represent the negative numbers, or x is less than 0, by our inequality y is greater than the opposite of x minus 1. Because when we have negative numbers and we put them in our absolute value bars, we get the opposite of a negative number, which is our positive number. So that's what this opposite of x look like. Not the negative x, but the opposite of x. We represent all other values of x, or x is greater than or equal to 0, which is positive numbers and 0, by the inequality y is greater than x minus 1. Because when we put in those numbers from this set, x is greater than or equal to 0, in our absolute value bars, our x is always going to remain positive. If we put 0 in for x, we are going to use the equation on this side. So 0 minus 1 is negative 1. That gives us our point 0, negative 1. So we can plot that point. If we put 1 in for x, we also use this side because 1 is greater than 0. So we have 1 minus 1 equals 0. So our point is 1, 0. So now we can plot that. If we put negative 1 in for x, we use this equation. So the opposite of negative 1 is 1, minus 1 is 0. Now we can plot that point, negative 1, 0. I also put 2 in and got our y to be 1, and then negative 2 in for x and got our y to be 1 as well. So I can plot those 2 points, 2, 1, and negative 2, 1. And we can see the graph taking shape of our absolute value congruent angle. Our vertice is shift down 1 because we're doing an operation outside of the absolute value. So now that we have this graph, we need to determine if we're going to use a dotted line or a solid line. And since this is an inequality with a greater than sign, not a greater than or equal to sign, we're going to use dotted lines to connect our dots. So our dotted lines show that this boundary is not included. And now we need to determine where we're going to shade. Since the boundary is not determined and our inequality says that y is greater than the absolute value of x minus 1, we're going to shade everything that's greater than or above our boundaries. And we're going to test this by picking a point in the shaded region. So if I pick the point right here, which is 0, 1, I should plug it into my inequality and it should be true. So when I plug in 0 for x and 1 for y, my inequality says that 1 is greater than negative 1. And that is true, so we know our graph is correct. Our homework problems will give us more practice graphing inequalities. The main things we need to remember are being able to graph the equation beside the inequality, and then deciding if our line is going to be dotted or solid and where to shade our boundary.